Okay, here in the earlier I have posted you some numericals just to I told you to just practice, go for a practice. I think most of you might have practiced, and anyways we will go once again, we will go with those numericals today here. Those few numericals go there. The first one is check the correctness of physical equation. V square is equal to u square plus 2a square. So this is the numerical given there. So we have to check the correctness of this equation using the dimensions. Already we know we apply the principle of homogeneity. What does this principle of homogeneity say? In an equation, the dimensions of the physical quantity on the left hand side should be equal to dimensions of physical quantity on the right hand side. Okay, so now in this equation, v square is equal to u square plus 2a square. This v square is on the left hand side. So LHS is equal to this one. So first let us write what is this v. V means here it is the velocity. What are the dimensions of velocity? It is L1 t power minus 1. L1 t minus 1. L1 t minus 1. Okay. Now these are the dimensions of velocity. So here it is given as v to the power of 2. So L1 t minus 1 whole to the power of 2. So this is L1 to the power of 2, it is L2 t minus 1 into 2, it is t minus 2. This we got in the left hand side. Now coming to the right hand side. What are the given things here? V square, sorry, this is your right hand side. It is u square plus 2a square. So look here, this u square, this u is also the velocity, u velocity, a acceleration, and s the displacement. S is the displacement. For u, what are the dimensions? L1 t power minus 1. Acceleration L1 t power minus 2. And displacement nothing but length, it is L1. So just taking this into this equation, u to the power of 2, L1 t minus 1 whole to the power of 2 plus 2. This constant do not have any dimensions, and acceleration is L1 t minus 2, and here s it is L1 to the power of 2, L1 to the 2. So we are going to get it here 1 into 2, it is 2 t minus 1 into 2 minus 2, and plus L1 L2. So it is L3 and t minus 2. So look at this, the expression what we got here dimensionally. So these two cannot be added because they are differing in the dimensions. So our principle says here, if the two physical quantities are there and if they are having the same dimensions, then only they can be added. So here in this case, this is different and this is different. So that's why here this is not possible. So according to principle of homogeneity, the given equation is wrong. Okay, so like this we will be completing this problem. Okay, so this is regarding the first problem. So there you can take the screenshot, and once you can verify that, okay, and take the screenshot and just go through that. And in the second numerical here, check the correctness of the equation, physical equation, S is equal to ut plus half at square, where uv is the initial velocity and v is the final velocity and a is the acceleration and s is the displacement. S is the displacement and t is the time. So everything is given here. So only the thing is, what you have to do is writing the dimensions and after that verifying dimensionally whether the given equation is right or wrong. So just the same thing, applying the principle of homogeneity, we are going to check whether the given equation is right or wrong. So in this equation, what is, first let's see what is there in the left hand side. Left hand side, it is in the equation S is there. This is nothing but the displacement. What are the dimensions of displacement? L1. So these are the dimensions on the left hand side. And coming to right hand side here, right hand side, it is ut plus half at square. Okay. So now, what is u? Initial velocity, means velocity. Already we know the dimensions of the velocity. What are the dimensions of velocity? It is L1 t minus 1. So L1 t minus 1. And put a bracket to this. And this is the time. Time means it is, the dimensions for this is t1. Okay. So now bracket for this and t1 plus this is a constant and this does not have any dimensions, and this is acceleration. What are the dimensions for acceleration? L1 t minus 2. And for the acceleration I am writing here L1 t minus 2. Put a bracket to this and t, time. What is the dimensions for time? t1. It is raised to 2. Now first taking this into consideration, L1, only L1 is there, t minus 1, t1. So it is t minus 1 plus 1, 0, t to the power of 0, anything to the power of 0 is 1. So no need to write about this, write this, no need to write this. So only the thing left is L1 plus, and here look here, L1, this is, okay, for this I am going to write here t minus 2 and t2. So t minus 2 plus 2. So it is t0, it is 1. So no need to write. If 1 it is there, no need to write. So L1 and L1. So these are having the same dimensions, and according to our principle of homogeneity, if they are having the same dimensions, we can add them. And even if you add them, you are going to get as L1. The dimensions of that physical quantity will be L1, and it is RHS is L1. So here LHS is L1, RHS is L1. So LHS is equal to RHS dimensionally. So according to our principle of homogeneity, the given equation is correct. Okay, so we will complete the problem like this. Easiest, I think. Now you can easily do such type of problems very easily. Okay, now pause the video and take the screenshot. We'll go with the another problem. And look into the next problem here. Check the correctness of the physical equation. At the same time, check the correctness of physical equation. F is equal to mv square by r. The equation is given here, and F is the centripetal force Centripetal force means some force, it is force. Okay. Acting on a body of mass m. So m is the mass here, and performing uniform circular motion along a circle of radius r. R is the radius. With linear speed, means v, it is speed or velocity. Okay. So now F is the force. What are the dimensions of force? You use F is equal to ma, and m is m1, acceleration is L1 t minus 2. So the dimensions are m1, L1, t minus 2. Mass, it is m1. Radius is nothing but length, L1. Speed or velocity, we making it as by speed or velocity. So it is L1 t minus 1. So these are the dimensions given there. Now going taking the left hand side. Left hand side is the force F. What are the dimensions for this? M1, L1, t minus 2. Put a bracket to this. And coming to right hand side, here mass, it is given as mv squared by r, isn't it? So mass is m1, velocity square. What is the dimensions of velocity? L1, t minus 1, raised to 2, and radius is nothing but the length, it is L1. So I can write like this, m1, L1, 2. So it is L1 into 2, 1 into 2 it is 2, t minus 1, 2, minus 1 into 2, minus 2. And it is L1, so it is M1. So look here, it is L2 by L1, it is L2 minus 1, L1. So L1 t minus 2. So finally for this we got it as M1, L1 t minus 2. Put a bracket to this. Look here, the dimensions of left hand side is equal to the right hand side dimensionally. So according to the principle of homogeneity, the given equation is correct. Okay, so this is another problem for you. So I think you became familiar with this type of problems. Okay, now pause the video and take the screenshot of this. We'll go with the another problem. One more problem is remaining. Look into the fourth problem. The force is given by F is equal to AT plus BT square. So where T is the time, in this equation T is the time, and find the dimensional force. So this is F is the force. Find the dimensional formula of A and B. You have to find the dimensional formula. So here you have to understand that it is, the given equation is dimensionally correct. Dimensionally correct. So that's why they asked you to find A and B. If it is dimensionally correct, it has to obey principle of homogeneity, isn't it? So according to that, if these two are to be added, they should be dimensionally equal. If these two are to be added, they should be dimensionally equal, and their dimension should be equal to the left hand side. Isn't it? Right. So now that means the dimensions of this one is equal to the dimensions of this, and the dimensions of this one also should be equal to the dimensions of this. Okay, so now what are the dimensions of force? It is m1, l1, t minus 2. Okay, so now let us take dimensionally F is equal to 80. So it is m1, l1, t minus 2. And it is A, we don't know about this, what the physical quantity it is, and we don't know we can't write the dimensions directly. So we have to find it here. Time, t, t1. So if we want to this, I have to send this side, isn't it? So it is m1, l1, t minus 2 by t1. So it is m1, l1. 1 goes there and becomes t minus 2 and t minus 1. If it goes to numerator, it becomes minus 1. Minus 2, minus 1, minus 3. So m1, l1, t minus 3. So these are the dimensions of the physical quantity A. And coming to the dimensions of physical quantity B. So F is equal to bt square. What are the dimensions of F? m1, l1, t minus 2 is equal to b, and it is t square. T2, okay, t to the power of 2 like this. So now it becomes inside, whatever it is, no problem. So if I want b, m1, l1, t minus 2 by t2. So it is m1, l1, t minus, this goes to t minus 2. If it goes to the numerator, it becomes t minus 2. It is minus 2, minus 2, minus 4. So t minus 4. So the dimensions of B are m1, l1, t minus 4. Okay. So these are the dimensions of B. So like this we can find the dimensions of an unknown physical quantity given in an equation using the principle of homogeneity. Okay. Now pause the video and take the screenshot. I'll just give you those few things. And at last, the limitations. That means the limit, the way these dimensions are not applicable. Look at the 3 limitations here. It does not give any information whether a physical quantity is a scalar or vector. A physical quantity is a scalar or vector. So in a dimensionally we cannot find out whether it is a scalar or vector. So this is one limitation. The second one is we cannot derive the formula containing trigonometric functions. So these trigonometric functions, because they don't have dimensions. And logarithmic functions, they too don't have dimensions. Exponential functions, which have no dimensions. So we cannot derive the formula containing if the equation is having trigonometric functions or logarithmic functions or exponential functions. And the last one is, if a quantity depends upon more than 3 factors, suppose if you are finding some equation like, if you want to find the force, it's something like mvr. So other than this, more than this, if you are having 3 or something like another t is there, then we cannot go with this. Because we have only mass, length and time. These dimensions we will be doing all the things. So here, if the equation is having more, if it is depending on more than 3 factors, dimensionally we cannot find out an equation. Okay, and that's about this dimensions chapter. Okay, now pause the video and take the screenshot, and let's meet in the next chapter.